write something as we continue. So this program, this refers to programs that generally manage a network. They include NOS. This is network operating system. And the second one, protocols. Refers to programs that generally manage a network. They include network operating system and also the protocols. Okay. So we earlier on when we were in Form 2, we learned about a protocol. So remember the terms some terms which we used to refer to this networking as in Form 2, we used something like IP address. So we said an IP address in full is internet protocols. So this IP does the addressing and so on. So we discussed this one in Form 2. Now those are key things when we are talking about a network. For a computer, remember there are some devices in the computer that take in the network. Like we said, the computer cannot work without an NIC. The NIC is a network identity card. The ports huko nyuma za network. So without the networking identity cards behind there, so the computer won't take in the network part of it. So let's continue. So network operating system. So as a subtopic, we discuss what it does. Network operating system. So we write it involves stroke does the following. Managing sharing of resources. A resource we said is like a printer, anything. Something that is connected to the network and can be used to do something in that network, like a printer. So when we have a common distributor there, we have a terminal. So we said there's something called a DTE, data terminal equipment. An example of a data terminal equipment ni gani? Yanakumbuka? A data terminal equipment like a router, a hub, and so on, switches, and maybe 2 seconds transmitting data around network, transmitting data around network. Next one is respond to requests. Respond to requests from application programs. Respond to requests from application programs running on the network. So next function of the NOS is enables nodes. So we said a node is anything that is connected to the network. So enables nodes on the network to communicate. Enables nodes on the network to communicate with each other. Next one. function, another function for NOS, Network Operating System, is implementing network security features. Implementing network security features. Implementing network security features. Security features. The last one for now, supporting services. Supporting services. Examples of NOS, Network Operating Systems. So we name a few examples of network operating systems. There's a Linux. These are examples. Linux, Unix, so we write protocols, subtopic protocols. So these are a few. So go to protocols. So protocols. So we write our rules and technical procedures. Rules and technical procedures. Rules and technical procedures. Technical procedures that govern communication. Between different computers. Between different computers. So now, how does these protocols occur? Because remember we said these protocols are set. Now we have written set of rules and technical procedures that govern communication between devices. That is why you find that we have different phones, but those different phones can connect to a network, and those different phones you can communicate via them. Not that a person having a Samsung, you cannot call a person owning a Techno. Is that time you are saying now my iPhone is stronger than your Samsung, but both can communicate. You can call a person with your phone, although maybe the other part can be, maybe the other person can be having a slightly higher one, but both of you can communicate because they are set of rules and standards. Remember, we have been saying of these standards that these standards that are set there, they are governing the communication between these devices. That this device, you can call via this device and the receiver will receive. So you, if you want, as I said in our previous class, you cannot develop a new phone. You want to be a developer now, you develop your own phone, and then you set your own standards. There are rules that govern. If you want to set up your network, a device like a router, you want to develop a gadget that can be able to connect others like routers. So that means you cannot overpower what is existing because you will be offending the laws, or you will be breaking the laws. So there are laws or standards which have been stated somewhere. So if you want to develop something, you have to check for the standards or the rules for governing that whatever you are developing, so that now you cannot develop something that is out of. Because if you develop something that is maybe you can be used to hack the other person, that is a criminal offense. You know. So these protocols are there so that your gadget you're developing, if they are to connect to a network, both devices should connect. It won't say, oh, this one is for 2000, this one is for now, but both should connect. They should be having the same standards. So there are standards that are already there. So these protocols, this is the keyword. These protocols, we'll be digging much deeper into now these protocols we're talking about. about when we were doing internet and emailing for one. We also mentioned the protocols, and even now we are doing this for the first topic, data. And remember the question, there's a question we did here, or it was in your exams, that was saying data communication modes. You people, data communication modes. This one is different from the term method. When you are told data communication method, there are three: manual or electronic, those ones. But when we are talking to modes, simplex, half duplex, as we said, half simplex, half duplex, duplex, and also full duplex. Where we said now in full duplex, the exchanging of signals is both ways simultaneously. A sender can receive at the same time the sender is receiving a message. So you can send, and at that point which you are sending, you can also be receiving. We said we used an example like a phone, the mobile phones. You can call and you are arguing. You're arguing. So that argument here, you can talk at the same time, there's a sound coming in. So you can send and receive at the same time. Half duplex, we say this one is like a walkie-talkie. That for police, you're saying tango 1, tango 2 over. So when you are saying over, now the next person there who is receiving the message can start be talking to you now. And then we said of simplex, this is the now, the current one. The simplex, we said only one device is allowed to send and never to receive. Like we said, like a station, a radio. So the radio signals that are coming to your radio receiver, you cannot go to your radio and start saying, hello, I want to talk to you. No, the person at the radio, you will only be receiving. That is simplex. So the station at where those people are, that is the sender. Your radio, your gadget which you have, the TV or wherever, that TV, that is the receiver. It can never send a message back. So, and so on. So this one are modes. This one is modes, and for the methods, these are electronic, manual, I mean, there are three also. So let's distinguish between methods and modes. What's the question in this? So that now we do not come back again here, because I said explain, state and explain the data communication modes, and we did not write this one. And you find maybe others were writing this one, like 2 or 3, and they were not explaining, and you are told to explain. So you should find some words to add there. So now these are modes. They have the full and the simplex mode. And remember, we do not mix those two. So let's continue with these protocols. So as a topic, how protocols work. How protocols work. So that now we can be able to know now what we are dealing with now, the protocols, how do they work? Because we have said they are set of rules and procedures, technical, that govern a communication between two devices that are connected on a network. So both should be on a network. So how does these protocols work? So we write data transmission process over the network. Data transmission process over the network has to be broken down into systematic steps. Systematic steps. Each step has its own rules and procedures. Each step has its own rules and procedures as defined as its own layers as defined by the network protocols. Network protocols are designed after network protocols after the open system interconnection. After the open system interconnection, into bracket OC model. So there's this key part here which we have to name it now before we continue. So let us look first here. So we have said protocols are set of rules. That is key. That network protocols are set of rules. So we have different rules. So there are many, not one, there are many. Now in these rules, they are set into steps. These steps are called layers. Oh, another statement we write as we continue. These steps are referred to as layers. So we have layers in these network protocols, and these layers are key. So in exams, we watch here now. In exams, you will be seeing of this term called OC. It is hard you being told what is an open systems interconnection. So remember we said of these mnemonics. Be aware of the mnemonics. You will find that it has been written OC. Now you are told state the layers in OC. So you have to remember, because there are two types of these layers. This is the first one, these are a set of rules. This is the first one, and this is another one. So we'll mention it later on. So this one for now, OC model. So before we start writing this OC layer model, so we said this, it has layers, protocols, layers. So those layers are like steps. So here we have 7 of them. 1, 2, 3, 4, 5, 6, and 7. So all of these 7 you have to know. After the end of the lesson, you have to know the OC model structure. Because now you will be, the exam might have, you will find an exam that, and it is written this way, 1, 2, 3, 4. So there's another one, another model for 4. But now we do this one. 1, 2, 3, 4, 5, 6, 7. So, and then you are told name layer A. So after now we have named them and discussed at each layer what happens, and that is key. And we are finished. We name a layer, we state the function of that layer, we are done. And that is the aim for today. So, and we have 2 models. There's this one OC and there's a network model. We see it later. So we write the OC model. The OC model. The OC model has 7. The OC model has 7 layers, namely. So you name them this way as points, and then we will be stating their work after the. So the first one is a physical layer or physical link. We use link, physical link. These things are cheap, you will see. So layer 1 is physical. And mainly, you find when we are drawing them this way, By the way, mark that. If they tell you the layer 1 is here, just know. But now, majority, when we are drawing this question, you will find that we go from up, down, or upwards. From down, upwards is how we count. Layer 1, layer 2, not from up now. We have to start from down. But now, after we have known the layers, so the first layer is physical layer. So it means it is this one here. Physical layer is here, downwards, not up here. So remember, as you are going up is when you are increasing the number of layers. So most questions written this way. So when you are asked A is it at which layer, 1, 2, 3, 4, 5, it is the fifth layer, and you will name it and state it. So we write here, these are physical connections. These are the physical connections. These are the physical connections. These are the physical connections done via cables, on a network. So as the term is, I'm explaining this one. So we have said the physical link or the physical layer. This part, so what comprises of the physical layer? It is what the physical parts of the components found on the network. So when you see a cable, that cable falls under the physical layer. The cables. So meaning there is a data that is moving through the cable to that point to tell it now there's a physical connection of a cable to a router and so on, or of what gadget we are using to send the network to that end. But these are the physical parts of that computer, the hardware part mostly. But now remember, we are not talking of this computer, we are talking of a network as a whole. So the network, you see there are different types of cables and so on. You're told this is a Cat6 cable. Remember I mentioned of Cat6 cable, these two pair twisted cables. Inside there you find the cables twisted. So these are physical layer, the first layer, that one's here. So the second part, the second one is data link layer, So this is the second one, data link layer. So we write adds error checking. So this one adds error checking. So this is where error checking occurs. So when you have connected your computer to a network and now there is an error that is coming telling you are not connected to a network, you are going to start something and there is a network error coming in, that is brought at this stage. Data link layer. So error check information and prepares data for going into. So by the way, there's this term here we used, physical layer. We said physical layer, these are physical parts or all the cables that are connecting. More so we refer to cables. Now, which other term can we use to refer to the physical? Hardware. But hardware, we know it is something tangible. But now that we're two physical parts, cables and so on. Okay, so data link, error checking. So by the way, you have to pick key things there. For the first one, we said physical parts of the networking part. So those parts that are visible and you can touch and feel and see, those are what we call the physical link layer. The physical layer. There's no need of writing this term. The physical layer. The second one is data layer, where now this data, the second one does the error checking. If there's an error happening in that network, that shows. The next one is network layer. This is now where network layer. So that is the third one, network layer. Address information. Okay. Network layer. Address information is added to the data packet. Remember we have said this one prepares a data for transmission. So now the network layer, address information is added to the data packet and routed to the receiver. And routed to the receiver. And routed to the receiver. The next one is transport layer. Fourth one is transport layer. We finished first the transport. So we write manages data transfer over the network. Manages data transfer over the network. So as the term said, this is where now the physical transportation of that data. We say the data packet. This is the point at which that data is moved from one point to the other. And then we have the next one, session. Session layer is the fifth one. Session sets up data transmission. Sets up data transmission session between two communication devices. Sets up data transmission session between two communication devices. So remember, for something to happen, so let me finish so that I can explain. So next one is presentation. Presentation, as the term is, presentation. 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 The last one is application layer. So presentation. So we write at presentation, adds formatting, display, adds formatting, display, and encryption of information. Adds formatting, display, and encryption on information. So now the last one, application layer. User application runs here. Right? So the seventh one, the last one, the application layer. Application layer. User application runs here and generate requests for data transmission. And generate requests for data transmission. Okay, so let's listen to this now. So we have talked of OC model. We have talked of protocols. We have said protocols are a set of rules and procedures that govern a communication between two devices. We should be having two devices communicating to each other, so that now in between there are protocols. So these protocols, we have talked of those procedures and the rules there. They are into steps. They are into steps that are designed using this one, OC model. The OC model or the OC model is in full open systems interconnection. So open systems interconnection, or C model. So they are into 7. The first one is physical, which is dealing with the physical parts of the network. And also we have talked here, this is the layer where now we are doing the wiring. Then using those cables to wire the networking. And then the data link, this one is established after you have wired the cable, is when now you will be able to check if there's an error coming in. Because you cannot know if that computer can take a network if you have not connected the physical part. So if you have connected a cable and you are hoping, you knew after connecting, you have to see a network and there's no network there. Now what tells you there's a data link? Those two devices have not been connected. It is at this stage. So you want to go up to this stage for you to know there's an error. This stage. Now, having had a data link, so that means we have a data packet. A data packet to be sent over a network. That is like a message we have to send to via, let's say you are sending a message. It has to pass all of these channels. That computer there, remember here we have said physical link. Mostly that device you are having, is it physically connected to a network and it's showing there's a network? If it is good. So now the data link, this one links the receiver and the sender. So these two devices here, we are linking them via the second one. So that this one and this one, there's a link, there's a route between the two. Now this network gives an address. Remember we said of addressing. An IP address. So that now those different, because we said every device connected to a computer has its own address at the computer level, at the network level. Everyone, so that now if we give at the computer, if our computer is given, let's say like an IP address of 2, that means there is no other computer that has this one, the 2. In that network, on that network. So that means when we are sending a message over from that device to the other one, there's a route that is being established that this computer A and B, there's a route that has been established at this network layer, and this route is able to identify this B from the rest. So that now when we are sending something, it only goes to B. Because we have its address, like a home. When we are sending a person to a person's home and we give the person an address, the person won't go to another person saying, oh, I was sent to an address. If we tell you go to that room and that house is written number 25, we go to that location, find an address and so on. So, and that is how this behave, the networking, they behave that way. So if we have an address of a computer, that computer will be having a route to it, and we know that computer has this address and that message. So that's a memory, and we say a computer because a computer does everything that is that a human being is doing. So meaning we are emulating what we could have done manually. So if I tell you now X is 2. And if tomorrow you come and again and I ask you, what did I tell you? There is the value for X. And again you tell me the value of X is 2. It means you stored that value and now you're giving it to you. Like we said now, and another person will come and I've forgotten. So that forgetting, we said it is like temporary. When you are told at that juncture, you know it. But if you go later on, you forget the temporary parts in memory for the computer. As you remember, we have to RAM and ROM in that aspect. So let's continue. So this transport session, remember, for you to even to carry your luggage from your home to some place, you have to establish a route to pass through. Where are you going? So this one manages this movement from this one, movement from this part to this receiver part. So managing like a car moving from this point to this. Now, before you go booking, like when you go to our local place, you go book a car. So that car you book, you are given a session. You are told you are with people will be traveling at night around this time. So that's a session created for that particular moment. So a session, let's differentiate between transport, because we have said transport, it is managing that movement of activity from one place to the other. Now that session, because now if we tell you we have to move this desk from this point to this point, and I have not allocated you a session telling you do that activity at specific times, so that is now the session. So after now it knows this luggage, this at the transport layer, I'm supposed to carry it and take it to this point. Remember, I'm doing it physically here, but that is also what is happening at the computer level, at the networking part. There's things there inside that are doing those things. So they pack. So remember, even the batch processing, things collected together in a batch and then transported for processing. So in this, so the transport will manage that movement. But when does that movement occur? It occurs in session. So you allocate that one. So the CPU and wherever will do that. The work. Remember the work of operating system in Form 2. One function for an operating system. Organ is called. Yes, called? Transport. Ryan, in your school, were you taught? Yes. Resource sharing, but you did not say that. Resource sharing. The next one, manage the input there. Managing output and input devices. Because when you connect your a mouse, this operating system will tell you if the mouse is connected or not. Another one? I am saying I heard you. It's okay. So let's finish this one. So a session we have said it is that time it is being allocated for now that transport to occur. The transporting of that data packet from one to another. So now presentation. Remember the last one, this is what we see. This is what we see. The user. This is now. You see, when you click here, we said you are sending a message, hello Festo. So we write that one, email. And then before you click the term send. So after you click, the message has been sent. So that clicking is what now we are seeing. Whatever happens behind there, and now a feedback or there was a message that has been sent from one end and it is coming to you now, and there's a pop message saying, oh, you have received a message to view. So that viewing is now the application section. So the intended application, which application, types of application software? Okay. Application software. Hey, we are doomed. Yes, you. From South Africa. Do you say? We were told applications. Yeah, one. Alex, application software. Yeah, Susan Suna had very cool. What would you do? You know what is an application? Yeah. Yeah, I'm asking the definition. Okay. So I think we have explained everything. So this presentation, we have said the session that allocated time for it to occur, that transport to occur. Now the presentation is the actual now, because we have written for presentation as the formatting, display, encryption, wherever. That data, because remember, this one session has not yet moved, because this one has been allocated. You at 10 to 12 be moving. That is the computer now commanding those resources. You move this data from this end to this end at this point. now presentation is now taking that data, formatting it, and moving to wherever the receiver is. So doing the encryption is encrypt is what? Afande. Very soon. Yes? Have you ever heard of the term encrypt? Okay, you people, you are students of English. You learn English. Students of English. Is that with you? Yes? Encryption. So we said this is protecting the data. So using passwords and so, but there is a way of encrypting data. We said there's a way. Like let me say, how do we stop eavesdropping? That person who is coming to your work and doing pips has used K. Okay, the person is you. Then you. So you have chunguri earrings. You are peeping. Huh? So that is eavesdropping. How do you do that? How do you prevent? Let's say like you people when you are talking, I had someone, Joy, you come here and say a term, but in my case I said, this term I know it. But now, my way, how I know it is not the way you know it. You can come here and say, the gazelles to come out. Yeah, you wondering who are those gazelles. But now in your language you know that the gazelles are some things. Yeah. So that is like encrypting. So you only know like now when I send you something called KW, you know this is our West. But where is it? So there is a way how the computer encrypts the data so that now you, who is behaving maliciously on the network, maybe now there is a malicious activity you want to hack, you want to do whatever. Now that data that has been sent, for it to be transported safely to the location it is going, it is encryption and so on. So let's know of this one. Now it is key. Hizi vitu si ngumu. Ni wewe tukikaa vizuri uangalie ya kwanza ni physical data link. After data link you have a network. After network you have a transport. After transport session. Yeah, session, presentation. Presentation, application, what the user will see, and so on. So, leaving alone the two words in English we have used there, but those keywords, like we said in here, data link checks for errors. If you are told state the work of the layer 2, just write checks for errors on a network. Hey, that is okay. But now maybe we are writing too much there because for explanation purposes. Who has a question? And this? Yes? That will Christy. Christy no more. Yes? So let's listen, maybe we will help with answer. In the second OSA model, it is called OC, but it's okay saying OSA. If you say OSA, you will forget. OSA, where you, OSI, OC. Okay, so second one? What is dry running? Joan, opening your mouth. John, running.
Alex, to go through a program to see if there's any error.
So, you see, manually. But now, remember you are not altering anything that is happening through those wires, through that cable, whether wired or wireless. So the movement from this device to that one, in between here you can't see anything for you to alter. So, the dry running is not even related to this one. From the term manually checking for errors. By the way, that comes too. I don't want to add anything else here because if I add, you will get confused. But the idea is simple. the OSC model, I won't add much because I want you people to know this part. It is key. If you want to be able to know this part, italeta shida. But